Good afternoon, everyone, and welcome to this 8th and final session of the 9th Annual Academic Symposium here at Eastern Nazarene College. We're delighted to have you with us as we hear from some of our students, especially from our engineering program this afternoon. For those of you who haven't been with us, I want to take just a minute to take care of a couple of housekeeping matters. Most of you, I imagine, have become Zoom experts over recent weeks, but this call is configured as a webinar rather than a traditional Zoom call, so the settings are a little different. You'll notice that as an audience member, you can see the panelists, but cannot actually see other members of the audience, can't see everything that's happening, but that doesn't mean that you can't interact. So just want to make you aware of a few things. First of all, as with a normal Zoom call, there is a chat function, and using that chat function, you do have the ability to send chat messages to panelists, as well as to the audience in general. You can decide how you want to address it in that way. And we'd encourage you to use that to send your best wishes and words of encouragement to our panelists. You also can use that as we go along to submit comments and questions during and after their presentations. If you think of questions that you maybe would like to just direct to one particular person, or if it comes up out of sort of the context of what's happening in that moment, there's also the Q&A box, which is a convenient way for you to direct an answer to or a question to a particular person, and they can respond to that in written form there. We also do have the option, again, if the context and time permits, for you to ask for us to turn on your microphone, and then you'll have the opportunity to speak directly with our panelists. So there are different ways of interacting, and certainly want to encourage people to be thinking about that. It's part of what makes this a rewarding experience, is to interact with members of the audience. So feel free to contribute as we go along. This afternoon's session features two students from our engineering program. We have Caleb Golden, who's a senior electrical engineering major, and he's presenting his senior design project entitled Welcome to the Era of Self-Tuning Drums, a topic on which I have many questions, so I'm looking forward to hearing from Caleb. And then Sebastian Arboleda, whose topic is also a senior electrical engineering major, presenting his senior design work and on a real-time automated fake news detection system. We unfortunately are missing our third panelist, Yobo Ode, who may make it, but at the moment we have not heard from him. So we'll introduce him later if he's able to join us. But without any further ado, Caleb, the floor is yours.
Well, thank you for the introduction, Dr. McCoy. Hello, everybody. Welcome to the Academic Symposium. My name is Caleb Golden, as said prior, and this was my senior thesis. I was able to develop an automated drum tuning system, hence the title of Welcome to the Era of Self-Tuning Drums. It's a little weird not being able to see everybody today, but that's okay. I think I'll be able to get over it and present to you guys today. So let's get right into it. So the problem is not your typical problem, as you would say. You know, it's not something that we encounter on our day-to-day basis, but it's still a major issue to both professional and introductory drummers alike. You know, on average, it can take anywhere from an hour to 3 hours to tune a full 3-piece kit, which would include a bass drum and 2 tom-toms. But it also just depends on the experience of the drummer. So the question that I really asked myself was, how can I personally eliminate this issue? How can I create something to minimize or eliminate the issue entirely? So first, let's get into a little bit of background on when drums first became tunable. So Ludwig and Ludwig back in 1931 developed the first fully tunable tom-toms with the tension rod and mount assembly, or tension rod and lug assembly, sorry. And they developed the first standard sizes of drums, which were 9 inches by 13 inches, 12 inches by 14 inches, and 16 inches by 16 inches. The drum personally that I used for this design was a 12-inch by 14-inch because they're also widely available. But 12-inch by 14-inch tends to be a more common standard size to be able to purchase widely on the markets. You know, the design of drums has pretty much remained unchanged since 1931. You know, until I decided that I wanted to mess with that tried and true method to try and create this product. So firstly, I wanted to create a system that was going to fit both my requirements for what I wanted the system to have, but also the requirements that I thought a product that was going to be sold on the market should have. So of course, I wanted it to be able to constantly be retuning itself during playtime. I wanted it to be compact, so it would be small enough to be transportable. You know, you could even throw it in your drum case along with your drum. I wanted it to be battery powered so that you wouldn't have to be carrying around a laptop or a tablet or something like that in order to use the system. I wanted to be able to fully control how high or low I wanted the drum tuned. And finally, I wanted it to be affordable because no one wants to go and spend, you know, $500–600 on some sort of drum system, especially not if you're an entry-level drummer who might not know how to tune a drum. So saying all that, let's talk about some of the products that are currently on the market and how they differentiate from mine. So currently, there are no products on the market that can do what I have developed. You know, there are some that can tune the drum, or there are others that can just sort of find the tone, the frequency of the drum. But none really can tune and find the sense of can sense the tone of the drum at the same time. Some of these products include the Drum Dial Precision, which monitors the tension, the Studio Bot or TuneBot Studio, which detects the frequency, and then finally the TC Electronic Unitune, which will find the actual corresponding musical note to the tone of the drum. So let's look at some of my system requirements. So I came up with 4 main requirements that I wanted my system to have. So first off, it should be able to constantly and automatically monitor its tuning. To be able to do that, I then would need some sort of frequency sensor to be able to constantly monitor the frequency of the drum when it's being hit. In order to do that, I would then go from there, I would then need some sort of processing unit to take that frequency and convert it to a voltage, which would then require the use of some motors to be able to tune the drum itself from the tuning rods. So coming down from these, I would then sort of needed a visualization of what I wanted my system to look like. So this was kind of a flow down chart that I came up with. So obviously to be able to sense the frequency, I would need some sort of microphone chip that would be able to take an audio signal in. I would then need some sort of processing unit, which I ended up using an Arduino unit for, to be able to take that audio signal and convert it to a frequency value, which I would then need a frequency detection code, which takes the audio signal, converts it to a frequency, and then some sort of comparison code to find out where the frequency lies within a set of ranges that personally I or the user would set. Then from that code, you would need to send a signal to servo motors to then tune to tighten or loosen the drum, which meant that the servo motors needed to be connected to the drum tuning rods. So the microphone chip is pretty self-explanatory, but let's talk a little bit more about the processing unit that I used, the Arduino unit. So I used an Arduino MKR1000 because they're specifically made for audio manipulation techniques. You know, the picture there is really blown up, but it's really only about the length of my thumb when you look at the chip. So it's really small, really easy to place on a drum, which typically aren't too big themselves. And so the reason that I used it was because it was, you know, small, and also because it's relatively cheap compared to other Arduinos that have the same sort of architecture as it. So as I said before, it's able to process both the audio signals, but then it's also able to control the servo motors in one program, which was ideal because I didn't want to have multiple programs that I would have to continually switch in and out of the system. And as we said before, it's specifically designed for audio manipulation techniques. So of course, this is the main processing unit that I used, but I wouldn't have been able to do this without the coding behind it. So let's get into some of that. So I used the Arduino integrated development environment, as it's free and it's pretty simple to use because it's based in the C programming language, and it can be used for any official Arduino boards as well as boards that might have an Arduino architecture. It was really ideal because it's small, data-wise, it doesn't take up too much space in your computer, and if, you know, I said before, you only need to know some basic C knowledge to be able to go in and manipulate the code frequency values yourself. Yeah, so now let's talk about some of the actual functions that I used in the code. I won't go too far into depth with this, but I just want to kind of lay it out for you guys. So the frequency detection code was the main reason that this whole project works. It's able to receive the audio signal from the microphone chip when it's struck, and it processes that to obtain a frequency value using an audio frequency library conversion program, and then it outputs a frequency value to your screen. After this value is found, that's where the second function comes into play, which is the servo movement section, which uses a series of frequency comparisons to determine where the frequency range lies. Currently, the frequency range that I have it set, it's looking for 30 hertz ranges. So for example, 80 to 100 or 110 hertz to 140 hertz, you know, et cetera, et cetera. That's the main section of the code you would be able to go in and modify, where you can change it to have any sort of frequency range set that you would want. So anywhere from, you know, if you wanted to increase it to 100 hertz range, you go 100 to 200 hertz, or if you wanted to refine it even more to get to like a 10 hertz range, you know, 80 to 90 hertz, 90 to 100 hertz. So that's the main aspect of the code. And now let's talk a little bit about the servos that I use. So these are FETech FR5311Ms. They work on a relatively low voltage. They rotate 360 degrees continuously, which is ideal because then you can just keep turning and turning and turning. And they actually have a really high range of torque to be able to really tighten the drum itself. You know, they're relatively small. You know, they're probably only a couple inches long, but even integrating those onto the side of a drum it caused a problem with the curvature, and it just didn't look very pretty. So I ended up implementing them into the drum itself, which turned out way better because it looked a lot nicer, and it just fit the shape of the drum much more. Due to some funding constraints, I wasn't able to fully implement my system. I would have needed 6 total servos, and I was only able to purchase 1, and I'll show that to you on the next slide. So the system itself right now can cost anywhere from $150 to $190. It's definitely more than I hoped, but you know, before I said, you know, funding issues is a problem, but that's because the servos themselves are really expensive. I've got some ballpark prices for the 3 things that I used this project. And you know, as you can see, the servo itself is almost $20. And so when you're implementing 6, 7, or 8 of those, it becomes, you know, fairly expensive to then implement a system where you're selling it for a reasonable price, but then also trying to make some sort of a profit on it. So I'm currently in the process of looking for replacement servos that kind of work the same, do the same thing, for anywhere from $8 to $10 cheaper, which hopefully would I be able to cut the cost down to less than $100, which is ideally where I would want to place it. So finally, so this is what I ended up getting with my system. So as you can see, those are all the pieces that are put together. As you can see, it currently resides outside of the drum. I ideally want it inside the drum to then create a seamless transition between the drum shell and the system itself. As you can see, essentially what I did was I ended up replacing the original lug with a servo motor to be able to kind of make that seamless transition between drum and system. And it actually doesn't look too far off from the original lug, which was really what I was kind of going for. It's just definitely not as shiny as the original lug on the bottom there. Last but not least, let me show you a couple of videos. The first video that I'm going to show you is going to be, I'm just kind of laying out where everything is. I apologize if I sound really tired from the video. I think it was like 2 or 3 in the morning when I was taking this video. So if it sounds a little rough around the edges, I apologize, but here we go. I should be able to share computer sound.
Just a quick run through of what everything is and where it connects to. So this is the battery pack for the servo motor. So as you can see, I've got my negative input running to the ground, which is grounded by the Arduino MKR1000 itself. The power line is running over here to this alligator clip, which I've just got this little wire poking out of so I can plug it directly into the servo wire inputs. So here's the microchip, the microphone chip from Adafruit. Really handy little thing. I've got the inputs soldered in so they don't go anywhere. As you can see, I've got an input into A0, and then it's getting power directly from the Arduino, and then it's got a common ground over here from the Arduino. Then we've got the servo output signal line, which is input into 3, which will go into the orange input on this servo line. And then last but not least, we have the servo itself, which, as you can see, has just been epoxied into the drum and then connected here to the tuning rod.
Okay, so that just kind of laid out where everything was for you. I don't know why I told you where everything was input, but I did. And then last but not least, I'll show you 2 different videos on the system actually working in response to the drum being struck. So here's the first one. Okay, and the second. Okay, so the video on the middle right, as you can see that it popped up that it said the frequency value is 105 hertz. So the reason that it only moved a slight bit was because the desired range that I had set for it to look for was 70 to 100 hertz. So, you know, a 5 hertz difference is only a few, a few clicks on a threaded tuning rod to be able to lower that tuning range. And then the video on the far right was looking for 100 to, or it was actually, yeah, I was looking for 100 to 130 hertz. But as you can see, it showed that it was 176 hertz. So it had to move down much farther than the previous video to get it down to that frequency range. So as both videos showed, you know, it is able to detect the drum being struck, and then it's also able to input that frequency value, as well as tell you what it is, but then also move the servo motor in reference. So as you can see from the first video, the tuning rod was all shiny and new, and then in the second and third video, it was black. That's because I ended up 3D printing some of my own tuning rods, just because the length of the original was a little bit too long, so I printed some shorter ones, and they actually worked out really well until I started really tightening the drum head. And then because they're made out of just extruded plastic, their fragility definitely was shown. So sadly, the 3D printing, the 3D tuning rods that were in those videos are no longer with us, as they ended up breaking later that night as I continued testing with it. So in conclusion, you know, I was able to successfully create this prototype to where I can accurately measure the frequency and then move the tuning rod depending on that set frequency range. I do have plans to continue working on the product to add the rest of the servos. I'm just currently missing the funding needed for it, just because it is quite expensive to afford all these servo motors. But I do truly believe that with further funding and work, that it really could be, you know, a potential change to the drum market, you know, in the coming years. Speaking more on future plans, you know, I also continue, or plan to continue, to improve the frequency detection system, to cut out a couple overtones, and to give more accurate results. I'm currently in the process for a patent. I'm going through the patent application process currently. I plan to have it done by hopefully May. We'll see how it goes. And then hopefully sometime early next year, I'll know whether or not my patent was successfully acquired. I want to improve the overall housing of the system, as stated before, just to kind of create a seamless transition. And finally, I wanted to improve the ability for the system to integrate onto typical drum shells, so that you can just place it right on a drum system and it works. So here are a couple of references that I used. The first reference was where I got some of my functions for my code, and then the bottom was actually where I was able to purchase the microphone chip and get the overall idea for an audio detection program. So last but not least, I'd love to thank Dr. Cornley for always pushing us to add something more or make something look nicer on our projects, and of course for the continued love and support of my friends and family throughout the last year and a half of this product. Are there any questions?
Thanks so much, Caleb. So the one downside to the webinar format is that they're all, of course, applauding wildly for you, but you can't hear them. There are a couple of comments that have come in the chat box, Caleb. I don't know if you can see that, but you did get a question about what it was that made you decide to pursue this as a research project. So you mentioned, the absence and your own exhaustion as reasons for it, but tell us more about sort of your interest in the project.
Yeah, no, of course. So the reason I decided to pursue this project was I'm a drummer myself. I love to play drums, especially since this whole quarantine happened. I've been practicing a lot, actually, but I really dislike tuning drums, to put the least. It takes a really long time. And so I figured that I just wanted to, I don't know, I guess I just wanted to create a system to where I could actually use it and, see if other people would want to use it too. Because I know I definitely am not the only drummer that dislikes tuning drums. So I think that's probably the main reason that I wanted to pursue it. That, and of course I was made to, because it is my senior thesis.
Yep, great. Yeah, and Tony Steelman, I thought I saw your hand go up. So if you did want to ask a question, we've got a minute. You can just let me know. Just raise your hand again, and we'll turn on your microphone. But Caleb, I was curious. I didn't quite understand in terms of how the adjustments that are made by the motor, right? It's registering a certain hertz frequency,
yep,
and then it's making an adjustment. Does that mean that your is it estimating how far to adjust it? Does it have preset spots on the tuning rod that it associates with particular frequencies? What is the computer essentially thinking in response to the input that it receives?
Yeah, so it definitely doesn't have some sort of visual sensor for the tuning rod in it, but I went through and I was able to kind of make calculations as to how far the tuning rod would need to turn in order to be able to reach a certain frequency range, or to decrease a certain hertz or increase to a certain hertz range. So I actually went through and I was using a drum key to tune it, and I was taking measurements of how far, and then I would hit the drum and it would register a hertz value. So I was able to go through and kind of create measurement values to where I would then have the tuning rod turn to be able to reach that certain value. So it's not just kind of like a ballpark value. I mean, it kind of is a ballpark value, but for the most part, it is a measured and calculated value for the actual tuning rod being turned to go down or to go up a certain frequency range to a certain hertz range.
Yeah. Yeah, so Tony did contribute his question here about what you think is the potential demand for your product, and have you thought about bulk purchasing for the servos, and whether that might in fact achieve the necessary cost efficiencies? So any further thoughts on that, or what you know about it?
I have not currently looked into any potential demand, just because this was kind of a personal product to me. It wasn't until after Cornley approached me and asked me to apply for a patent for it that I realized that it could be an actual product to sell on the markets. So I definitely have to look into that. And I didn't realize that you could purchase servos in bulk. I guess I probably should have done more research on purchasing in bulk. But if I do put this into production, I definitely know that I would have to look into something like that in order to bring down that price. Yeah.
Okay, great. Well, Caleb, there is one other question for you in the Q&A box. And I'll ask you to open that up and write a response to Haley's question there. It kind of builds on the same theme here. But if we can transition now to Seb. Seb, if you want to go ahead and share your screen, and you can talk to us about your project.
Sure. Yeah, thank you everyone for attending. My name is Sebastian, and today I'm going to talk to you about my senior design project, which is titled A Real-Time Automated Fake News Detection System. All right, so let's get started. All right, I'm guessing we're all familiar with the problem regarding fake news. We've seen it in politics, in healthcare, and in all these different parts of our regular life. And these are just a couple of the most eye-opening statistics that I could find online. First of all, 62% of US adults get their news on social media. And on top of that, the most popular fake news stories of 2016 were more widely shared on Facebook than the most popular mainstream news stories. Now, there is a problem. I believe that fake news are actually detrimental to our democracy. When people are not able to know what is true, they're not able to make the correct decisions. And I think that's a really, really important problem that we are experiencing right now. Now, we have some solutions. In the past years, we've seen a good amount of fact-checking organizations coming up globally. I think there are around 140 organizations through the Pointer initiative. But the problem that arises with these organizations there are mainly two problems. The first one is that manual fact-checking is time-consuming, expensive, and unscalable. The other problem is, by the time a piece or a news article comes into the hand of these organizations, is because it's already being widely shared. And so millions of people have potentially read it by the time they see it. And then again, it takes some time. So they're probably gonna see some fact checking done on that news article probably a week later, after tens of millions of people have seen these fake stories. So my project is called Facts, and what I intend to do is I want to make it so that it is on a mission to prevent the proliferation of false and incomplete knowledge globally. So I deeply respect what fact-checking organizations are doing. I think it is an amazing job, and they're doing an amazing job, but we need to be faster than that. And we need to be able to counteract all these fake articles that are coming up. So there are two main goals that I'm still working on them. And the first one is I want the system to be able to expose misinformation at scale. What that means is I want the system to someday be able to scan the internet and see different, 100 articles per a specific period of time, fact check them, and then publish the results somewhere else. Because I feel that we need to do it on scale. Now, the scary part is we have some technology that can help us see if a claim is false or true, but we also have some new technology, some new artificial intelligence technology that can actually generate fake content. And regular humans, we're not able to determine if it is computer made or human made. So imagine that we already have technology that's summing on top of all the fake articles that people are posting online. And the second goal that I have is that I want anyone, anywhere in the planet, to be able to know the veracity of an online article based on our artificial intelligence fact-checking assistant. So as I said before, fact-checking organizations are huge right now, but they will follow some sort of of a specific fact-checking process, which can be divided in three. The first one is claim selection, which is when you take an article and you select not only the objective claims on the article, but the research-worthy objective claims, because you cannot fact-check every single objective claim if it is not relevant. And we see them sometimes in some discourses of politicians. You know, there's some, they might throw some objective facts in it, but if it is a date, if they're talking about a specific date of a specific event that is not relevant to what they're talking about, you don't really want to fact check it and lose some time on it. The second step of the fact checking process is evidence extraction. So once you have these objective claims, you want to be able to get some evidence that can either support it or debunk it. And with that comes the third part of the fact checking process, which is I already have a claim, I already have a piece of evidence. Now I want to know if that evidence is supporting or debunking the claim, and I want to label it. And then depending on the amount of evidence that I get of one side or the other, then I can make a decision of, okay, this claim is true or false. And then once I aggregate all these different claims, then I can make a final label of the news article. And I can label it as truthful, deceitful, completely fake, etc. So the idea was, okay, we already have a system set up, and that's the one that I just explained. We just need to automate it. So what I came up with was an architecture that could simulate this and make each step a different system. So as we can see, we first have the claim detection system, which is the one in charge of extracting the objective claims from the article. And then all these claims go into our evidence retrieval system. This evidence retrieval system is basically a search engine that has around 520 indexed reliable sources, and it scans through them, and it's able to get some written or some evidence in text format. And then once we have these claim evidence pairs, we put that into the stance detection system, which is an AI that reads or takes the claim text and takes the evidence text and outputs a label saying if the evidence is supporting or debunking the claim. And finally, all this information goes into an aggregation system, and this is the one that is in charge of giving a final label to the article. So for that, I came up with this architecture. Because I wanted to be user-friendly, I set up a front end with Vue.js. And here a user can just input whatever text it wants. And then this front end makes a call into our API service, which is built with Flask and Python, which then takes our core systems. These are the most important systems in the project. And as I said, they are the claim detection, evidence retrieval, and stance detection system. As we can see, the claim detection system is actually built on top of an initiative that's called ClaimBuster. ClaimBuster is an artificial intelligence project that is able to extract research-worthy claims from political text or speeches. Then the second system, as we can see, is built on top of a custom search engine. The search engine, as I said, indexes around 500 plus reliable sources, and then it's able to extract the important ones. And then finally, the artificial intelligence system that I'm using for stance detection is built on top of the natural language toolkit for Python, and I'm also using TensorFlow for it. So a lot of these tools are open source. And the reason why I set up an API is because I want people to be able to build on top of this. So if someone, and actually had this, someone asked this question in one of the modules, if someone is trying to make a new system that can transform speech into text and then run through facts to see if whatever they're saying is false or true, they can do it as long as they connect through my API. So I want anyone with the initiative of trying to solve this problem to be able to use my product. So Let's start with the claim detection system. So there are three main functions. This system tokenizes sentences and then parses them, and then it does an API call to claim buster. So the tricky part in this system is the tokenization. So I'm using natural language processing techniques to divide the article body into individual sentences, and then extract specific features from these sentences, and then I'm sending them to Claimbuster's API, and that helps me to retrieve the research-worthy claims of the article. Then this goes into the evidence extraction system. Again, I also use NLP techniques in here, but this one is a little bit more complex because I need to generate a query that I'm going to put into the search engine based on text features. And some of these are, if I have a sentence, what are the most important parts of it? Well, I would say definitely proper nouns, verbs, adjectives, and if there is any relevant number, if there's any relevant digit or statistic, I need to extract it. So this also has they also have a small artificial intelligence module that's able to extract important parts of each sentence and then build a query for the search engine. And then with this query, the search engine is able to search through all these websites and be able to take specific evidence text. And then finally, the stance detection system, it uses artificial intelligence to detect the stance of a piece of evidence on a given claim. So again, once you have a claim and evidence pair, the stance detection system is able to generate a label with the text agree, disagree, or no stance. So obviously, agree is if the evidence is proving the claim. Disagree is if the evidence is saying this claim is false, and then no stance means that yes, the evidence is talking about the claim, but it's not really making a stance on it. So it's just a piece of information that's relevant to it, but it's not. We cannot really say if it is supporting or debunking it. This is a little bit of the overview of the tech stack that I used. My main languages were Python and JavaScript. Databases, I use PostgreSQL and MongoDB. Flask to serve my API. Vue.js as my front end, and then TensorFlow for artificial intelligence, for building the deep neural networks. And then some task queues and a CI/CD pipeline, so the development became more efficient after I built this thing, because there are updates that need to be done all the time. There are new websites that had to be added, so I had to build a pipeline so that I could make changes without breaking anything that was already made, but be able to iterate fast over it. So here's a demo. It is in YouTube, everyone. So if you want to take a look at it. And claims to have. Yeah, so here what we're seeing here is the front end of the application, and I'm pasting a news article from a website that it is claimed that NASA admitted that climate change didn't happen because of greenhouse gases or anything like that, but only because of the changes in Earth's solar orbit. So here, as we can see, we inputted that, and then we pressed fact check. And now we see the objective claims as highlighted values in the document, and then we can see those little cards on the side. So it is color coded as well. If you see that it's highlighted with a red color, then you can know that it is a false claim. And then on the cards, we see the evidence. And then on the bottom of each card, we actually see the URL or the link of that evidence. So in case there is a mistake with our labeling system, you can go ahead and click on the link and go into the evidence article by itself, and you can take a look at it and read it. Now, the cool thing about facts and what makes it different and what I was trying to do is fake news are really complex. And a lot of times, as we can see with this article, the first two claims are false, but then they managed to put a couple true claims in between. But then the conclusion is based on a fake relation between the first two claims and the bottom two claims. So yes, one of the main factors of climate change is Earth's solar orbit. but that doesn't, and that is true, but that doesn't mean that is the only factor that's impacting climate change. And so that's sort of what this document was trying to say. It first made two wrong claims of NASA's history, and then went on to say, yes, NASA published this paper saying that that changes in Earth's solar orbit were the main issue here, and that the conclusion was based on a wrong relationship between these two. And so, well, for future work, as I said in my abstract, I see this as a stepping stone towards a complete set of tools that can help expose online misinformation at scale. And again, that's the reason why I set up an open API, so that anyone that has an initiative that can help with this cause can build the tool that they need, and then connect to my project through that REST API. I also want to add functionalities to continuously scan the web, searching for fake articles. As I said, the idea is that we can actually scan misinformation at scale. And finally, I want to add a list of known misinformation sites to the custom search engine. And this is because a lot of times, one of the easiest ways to predict if an article is fake is not only by checking the true claims on it, but by checking what other sites have cited this article. So if there are 5 sites that we know that are constantly publishing fake information, and they're citing this article for whatever article they're trying to republish, that's a pretty good indicator that this is going to be fake. Well, thank you. That was a little bit of the story of facts and how it works. I want to say thank you to Dr. Connolly for all his support, and for my family and friends for their unparalleled support, and for Tony Stillman, that I see that he is in the call, for giving me this setup back here on the Wi-Fi. And yeah, if any of you have any questions, don't hesitate on asking me, or you can also contact me.
Great. So Seb, we do have a question here that comes from Cameron, who'd like to know if you think that if this tool could have helped with the spread of COVID-19 misinformation just in these recent weeks. When the outbreak first started, would your tool have been helpful in that context?
Yes, I believe it could have been helpful. The only part of the project that is not as accurate as I would want it to be is the artificial intelligence part. So the claim detection system works amazingly, and the evidence extraction system also works pretty well. So you can get pretty good evidence on whatever claim they're doing. But then the labeling system, because it is a really complex AI, it needs a lot of fine tuning still. So it is 90% accurate on telling if a piece of evidence is relevant or not, but it is only around 70% accurate at predicting if the evidence is supporting or debunking the claim. So I actually thought about taking that out in the meantime, so that people can actually get evidence on those COVID-19 claims that were going through messages over WhatsApp and the social media, and use this as a search engine. But yeah, I think it definitely could be helpful, even today, even nowadays.
Mm-hmm. Mm-hmm. Yeah. There is another question here from Tony, noting how complicated this project is. And do you know, are there any of the sort of big data analysis companies out there that are developing similar sets of tools and working, with what would obviously be a very helpful initiative?
Yeah. Yeah. As I said, the level of complexity gets really high really quickly once we get into NLP. That is natural language processing, and the AI that manages these tools. Because, well, first of all, English is a really, really complex language. Any structured language is really complex. English is a little bit more complex even than that. But so yeah, it's really hard to make a machine extract information from a written text. And so that's why it's easier to get evidence from it, because we already have some models that are kind of doing this. We have search engines like Google, so we have had the technology out there for a while. But one of the main challenges that we have nowadays with artificial intelligence is that we need to be able to make a machine understand what someone is saying through a context, and not only by mapping words with other meanings and you know, like doing all these language maps and trying to find synonyms and stuff. And that is something that comes with abstract thinking, and it's really hard to replicate. But yeah, that's the most complex part, and there are several organizations out there that are trying to do this, and this is basically the holy grail of natural language processing.
Great. Yeah. One last question, Seb. Did you say, I think I missed it as well, in terms of the accuracy, the sort of confidence percentage in terms of the results that you have gotten with this, do you have a sense of where you feel like your tool is right now?
Yeah. So as I said, we'll have to divide it into different components that make this. So the claim detection system is around 90% accurate on extracting objective claims. So it works really well, even though it is an NLP based tool. Mm-hmm. The evidence extraction system also works really well. That is the search engine. It extracts evidence with around a 90% degree of accuracy. Mm-hmm. The issue comes once we make the claim and evidence pair and we put it into our final labeling system, which is this stance detection system. And the reason for that is it is 90% accurate when trying to determine if a piece of evidence is related or unrelated to the claim. So it's really good at telling you if the evidence is actually talking about the claim. But then once it knows that it is related, yep. It is only around 75% accurate on telling you if the piece of evidence is supporting or debunking the claim. So, okay. So right now a human is much better at predicting if a piece of evidence that we know that is related to a claim, it is supporting or debunking that claim.
So that actually leads then to what was a related question that I think I initially misunderstood, which is as your system produces results, is it also offering some kind of confidence rating to say we are highly confident of what of the results that we're producing, versus we're not completely sure that we've made the right correlations? Or would that be a further way to develop the tool?
Yeah, so each module actually outputs, along with the results, a confidence estimate. It also goes between 0 and 1, so it is also sort of a percentage. The front end doesn't show it because I try to make it as user-friendly as possible, so actually those numbers are not shown in the front end. But if you connect to the API with each result, you will see the confidence that the system has in it. And if it goes past 85%, it is pretty, you can basically say that or bet that it is going to be factual.
Great. All right. Well, thank you, Seb. If people do have other questions for Seb, you can feel free to drop those in the Q&A box and you can answer them there, Seb. But we do have our third and final panelist for the day and for the whole symposium, Yobo. So bring it home here for us. Yobo O'Day is a senior computer engineering major, and he's going to be talking to us here for a few moments about self-efficient and controlled charging system for laptop and Android devices. So, Yobo?
Hello, everybody. My name is Osamu Jude O'Day. I am a candidate for the Bachelor's of Science in Computer Engineering, and today I'm going to discuss about my self-efficient and controlled charging system for laptop and Android devices, short for SES and AD. Before I discuss about the problem, I first wanted to talk about the motivation and the reason why I wanted to go into designing this system. So the motivation behind this whole creation is the fact that I was tired of my computer overheating over the littlest things. Like, say I had an assignment where I had to do a few hours of coding, and my computer would just wouldn't respond well. It would begin to overheat. Even though my computer did have a fan, it just came to the point where the fans could no longer keep up with the rising temperature of the computer, which leads into my problem. So when a computer is overused and is not given enough time to rest via cool down, it begins to overheat. And everyone knows when a computer overheats, it begins to develop issues like the motherboard, the microprocessor, and the batteries. So it begins to affect important components of your computer, which in turn begins to slow down your computer. And because of these essential parts shutting down, the consumer, which is you and which is me, we would have to end up purchasing a new computer, which in turns is pointless because we would end up running into the same issue. So we would just end up spending money all over again, just trying to fix the same problem that we assumed that we fixed, but clearly we did not. So to fix this problem, I created a system which main purpose is to cool down your laptop. So the system that I created is a case that attaches to your laptop that has fans on the bottom, which cools it down, not only with the fans, but also with the added ventilation. So heat doesn't build up on the bottom anymore. And also this case also comes with as a charging hub for your Android devices. Background to my design, yes, there have been creations to fix these problems. Like for example, this design right here, which is a cooling pad with traverse fans. But these kind of patents haven't really been issued. But because of the creation of these patents, there have been other products and other designs that have come from this to create a whole new architecture of things. Here are other prior arts. So for the first figure, which is a laptop cooling and docking station, the second one is a laptop cooling pad, and the third one is a conductive laptop cooling pad, which they all have in similar as the point. The main focus is to cool down your laptop when it begins to overheat. Here are prior arts of things that are actually in the market right now. And these are the names and the prices. But when it comes to my design, it's clearly a state of the art because my design is a case in itself. When you compare it to the other prior arts that have been created, they're very bulky, they're heavy, they run on battery, so they could die anytime. And I'm pretty sure a lot of us don't carry portable battery chargers. That's why my design comes in. So not only does it effectively cool your laptop, it runs on solar power, meaning that when the battery begins to die, it turns off the fan and it begins to convert sunlight into electricity, which starts to charge the power bank that you have under the case. And it's fairly cheap because it's only $55. And what's so good about this case is that it's very portable. So you can take it anywhere with you. It's a literal case that you can take anywhere with you. These are my system specs. So these are just a little snippet. Like it was a long list of system specs I could have put, but I just decided to put the best ones that would best support my case, which is it has a built-in USB port, supports temperatures up to 105 degrees, adjusts power usage and drainage, and provides backup charging capabilities. My system requirements: system shall charge power bank using solar panel, be able to charge your handheld devices, have a built-in USB port, be capable of shutting power and switching to solar panel to charge battery to conserve energy, be able to let users adjust parameter of power, protect user from short circuits, overload, and reverse protection, basically protecting the user and its system from from the system crashing on itself. So when I was creating this design, I used some approaches. The methodology that I used was the design and integration. So basically, design meaning creating something new that hasn't been invented, that's currently not in the market. And integration is bringing together existing components and implementing it into my own system to make it something new that hasn't been out there. So here is the design. So I used an application called Autodesk Fusion 360, which is an application that allows you to create a schematic and use precise scaling and calculations for whatever layout that you're going to use. And so by using this application, I was able to design my case that would precisely fit my laptop. So it's customized to my personal laptop. For the integration method, I used a solar cell, which I was able to create into a solar panel, because the current solar panels that are out there are currently way too big and they're not fit or scaled for a 13 or 15-inch laptop. I also used a solar charge controller, which its job is to monitor the power between solar panels and the rest of the devices. So it's basically, I would say, the middleman, the one that monitors how much power the power bank is going to receive from the solar panel, and also how much watts and how much drainage the consumer, which is the fan, is going to take from the battery. And it regulates if the battery itself doesn't have enough juice for it to switch and start conserving energy, so it can begin the process of charging the battery. This is the power bank I used to hold the charge, and the CPU fans used to cool down the laptop. So I used 6 CPU fans, one placed all the way on the left side, all the way in the front, and then one placed all the way in the back, so it could monitor the temperature of the fan. So it could, the temperature of the case, because it would be blowing cold air to the bottom of your laptop. So for my design architecture, I basically drew a schematic of how it would look and how everything would be placed together. So here you can see the solar cells, you can see the CPU fan, and you can see the power bank with the solar charge control. So this is my final product. So this is the bottom of the case. So this is where you would sit your laptop on top. You can see the CPU fans, you can see the power bank, and you can see the solar charge controller. This would be the top, which is the mini solar panel that you sit right on top of your laptop. So when you open it, it's directing towards the sun. So say you're outside doing something, you could be doing anything, and you're not using it. So it would be directing the sun. So currently, while you're not using it or using it, it would be continuously charging the battery. So when you don't need to, so when you are actually using your laptop and like your computer is overheating and like you see the sun is going down, what the case does, it will automatically just turn on the fans. So it begins to cool down your laptop whenever you notice that your computer is beginning to overheat. So this is how the final product looks. I want this to soak in. You guys can see it. Okay, so for when it came to testing my design to see if it did what I actually designed it to do, I installed an application called a CPU thermometer. Just guessing from the name, it monitors the temperature of your CPU. And so for me to quickly overheat my laptop, because I did this in an hour period, I turned on a lot of videos, I turned on a lot of games. I even covered the bottom of the ventilator on my computer so I can overheat it fast. Definitely wouldn't recommend that. I just did that for the test. And I also sat it by a heater because I wanted to see how hot it could get with it being used within an hour. So when the hour interval was over, I set the parameters so the solar charge controller could kick in and began to turn on the fans. So this is basically the temperature from start to finish. So this is when the first two pictures were when the, I don't know, can you guys see that? Can you see that? Okay. So the first two pictures just showed how the temperature is while everything is running in the background. And the last picture is when the temperature is going down once the CPU fans have been turned on and been running for a while. And this is a demo, which I'm gonna play. Earlier today, I showed a snippet of the temperature that my laptop was at. It was around 50 degrees Fahrenheit. As you can see, the temperature is decreasing. As you can hear, the fan is currently on. So for me to test this, I had to block the air vent for my laptop so it could quickly overheat. And I opened many tabs, many programs, many applications. I even played an hour-long movie, opened 2 games just to quickly heat it up for this experiment. And so that within the hour, the fans will be turning on and off. So let's see if the fans turn off. So you can see the 3 CPU fans here and the power bank, and then 3 CPU fans back there. And where this light is coming from is where the heat should be dissipating. So when the cold air comes in and it hits the bottom of the case, it should be taking down hot air, pushing hot air through the vents that I created for this case. Let me show you guys the temperature once more. So right now it's come down to 36. Oh, do you hear that? So the fans just now. So basically just the continuation of the video is just repeatedly showing the fans turning off and on, which it's supposed to do. So once you set the parameters, it enters a cycle where the fans will turn on for a short period of time and then turn off for a short period of time. Because you also have to understand that it has the power bank is continuously being charged, so that will overheat. So now it has to manage the fact that, okay, so you can't have your computer overheating and then the battery itself that's supposed to be, you know, powering the system overheating. So that's why I added the ventilation, so it just doesn't add up in temperature. So my conclusion is, creates a laptop case that cools your laptop and provides power management for other devices. The design will improve the lives of tech-heavy users. For example, for people who are like me or like everyone else that are going into engineering fields and has to do a lot of coding. Teachers that are doing a lot of grading, you know, architectures that are out in the field that are creating schematics, doing measurements on their laptop that are in the sun. So while you're in the sun, your computer is obviously getting hot. You might as well have something that not only will cool down your laptop, but will also use the energy from the sun to use basically renewable resources just to cool down your laptop. So you're just not relying on your computer's CPU fans. The design will improve the lifetime of most laptop and computers. Basically, that you can use, instead of, let's just say that you could only use your laptop for an hour before it starts overheating. Now that's no longer going to be an issue. Future work. So the future work that I wanted to do with this case is I wanted to apply the same knowledge that I had with the solar cells, and just to end up creating my own solar cell. So it's possible in the future, because solar energy technology is definitely increasing and it's getting better. So I would love to learn how to create my own solar cells so I can apply more current and voltage. I would also love to improve the design of my laptop case because I ended up using Legos. I was going to use the PCB, but I actually found out that the Lego pieces could actually absorb more heat than the PCB, so you could honestly use it longer because it had a higher temperature resistance. My future work, I would love to add a temperature sensor to automatically detect the temperature. Like once your computer begins to overheat, the system or the case will sense it, and it will automatically turn on the fan so the users currently don't have to set parameters. And yeah, and also future work, instead of the case just cooling down the laptop, it'll be actually capable of charging your laptop as well. That would be my future work. I would like to thank Dr. Cornley for his support and his love throughout this whole thing. And I would especially love to thank you guys for coming here and watching my presentation. Any questions?
Thanks, Yobo. It was a fascinating concept. And you answered one of my immediate questions, which was whether the Legos were an intentional design choice or just a question of material that was available, but they actually had desirable design qualities, huh?
Yeah, it actually, it's funny because the Lego pieces could absorb more heat than the PCB, which is, you know, the plastic for the 3D printers, which was very fascinating. So, yeah.
If other people have questions for Yobo, please feel free to put them in the chat and we'll ask him to address those. Yobo, I was a little unclear on one element of the design. So you showed us the open case with the laptop sitting in it. You also showed us the solar panel that you built. Yeah. Did I misunderstand? Is that the solar panels, are they resting in a lid that you
I'm sorry. I should have took like a better picture, but it's actually a lid that you can put a glass casing right on top.
Okay.
So this is just with the glass casing. So it's just laying down. As you can see, the wires, it actually goes into the Lego pieces and like it turns down into the case. Okay. So when you open it, you can't see the wires. It's within the case.
Okay. And so when the case is closed, does your laptop rest inside the case, or do you carry the laptop separately?
Yeah, the laptop is resting inside the case.
Okay.
Yeah.
Great. Yeah. Anybody else? Other questions for Yobo? All right. Well, Caleb and Seb and Yobo, my thanks to all of you for these fascinating presentations. I admire tremendously your creativity and the sort of practicality of the problem-solving skills that you have shown in these presentations here today. Thanks to the members of our audience for joining with us, and for all of those who've participated throughout the day and in the poster sessions and in all the different facets of the academic symposium, which I am happy to report is now officially closed. And that means I can finally go home and sleep. And I'm very happy about that. So my thanks, everyone. Hope you have a wonderful evening. God bless.
Take care.